Hardcoding credentials, connection strings, and other sensitive information in your application code is considered as bad. But then what is the alternative? If you're building applications on the AWS infrastructure, then AWS Secrets Manager provides a centralized and secure storage for your sensitive information. Secrets can be any information like passwords, connection strings, API keys, credentials, etc. AWS Secrets Manager helps you protect your IT resources and data by enabling you to rotate and manage your secrets. In this video, let's learn how to get started with AWS Secrets Manager using a .NET application. First, we will learn how to connect to AWS Secrets Manager and retrieve a secret using the .NET Client SDK. We will then see how to integrate AWS Secrets Manager with the .NET Configuration Provider and seamlessly use these secrets from your application code. We will also learn how to keep these secrets in sync as and when it gets updated in the Secrets Manager so that your application has the latest secret. Hello everyone, welcome back to this YouTube channel. My name is Rahul and I work as a software engineer in Brisbane. If you're new here, I make videos around .NET, Azure, AWS and DevOps. Without much delay, let's jump right into learning more about AWS Secrets Manager. Here, I have an ASP.NET Web API template which is built in Visual Studio using the .NET 6 framework. We have the program.cs, the weather forecast.cs and also the default controller which is the weather forecast controller. This has a simple get method which returns a dummy list of weather data. Let's see how we can integrate AWS Secrets Manager into this application. Secrets Manager enables you to replace hard-coded credentials in your code with an API call. Now it is a centralized resource that is accessible over a web API, and the .NET SDK allows us to connect to it more easily. If you're new to secrets management in general, this is a high-level flow on what happens in a secrets manager scenario. So the admin would first create the connection strings for this particular database and then stores the secret inside the secrets manager. Now any application that requires access to this database will retrieve the connection string from the secrets manager. This is done using the API or the SDKs which basically wraps around these APIs. Once the application has the connection string, it will use that to connect to the database. This is very much similar for other credentials, API keys, passwords, etc. Some of the benefits of AWS Secrets Manager is that it allows programmatically retrieving of the encrypted secret at runtime. It also allows us to store different types of secrets, and it also allows us to store other metadata associated with these secrets. Secrets Manager also allows us to encrypt the secret data using a secure key. This can be a default key, or you can create one of your own in AWS KMS, which is the key management service. Secrets Manager allows automatically rotating your secrets. Secrets Manager also supports resources that supports native rotation support. You can also extensively control the access to your secrets, which means you can pick and choose which application or specific users have access to the secrets in Secrets Manager. With Secrets Manager, you pay only for what you're using and there is no setup fees associated. So if you take a look at the pricing page, you can see that the pricing is based on a secret that is created per month and also per 10,000 API calls. So anytime you create a secret, it charges you 0.40 per secret per month, and then there's also charges per 10,000 API calls that's made to the Secrets Manager. You also have a trial period which you can start using to see how much it would cost for you. Or you could use the pricing calculator to come up with an estimate. When working with AWS Secrets Manager, there are some terms that you will keep coming across. Let's take a quick look over that. A secret consists of the secret information, that is the secret value, and also the associated metadata about the secret. A metadata includes the ARN of the secret, the name of the secret, a description, resource policy and tags. You can also specify the ARN of the encryption key and also information about how to rotate this secret key. Rotation is the process of periodically changing or updating the secret to make it more difficult for an attacker to access the credentials. A secret has different versions, which holds the different copies of the encrypted secret value. Anytime you create or update a secret, it creates a new version. Now, Secrets Manager uses staging labels. So it uses the AWS current, the AWS pending, and AWS previous to indicate the different states of the secret. Whichever is the current and active one is labeled as AWS current. The AWS previous indicates the last known good version, which was the last used one. The AWS pending is one that will soon become AWS current. That is during a rotation. Now that you understand the basic concepts in AWS Secrets Manager, let's see this in action from our application. So coming back to our ASP.NET Web API, here we have a hard-coded number which is range 1 to 5. This determines how many records to return back. Let's say, for example, we want to change this 5 as a secret value. Now typically, the number 5 is not a sensitive information, but we will just use this for the ease of demo purposes. We will later see how to use real sensitive values. So let's extract this count as 5 and use that in here as the variable. Now let's move this into Secrets Manager and see this in action. To add this as a secret, first let's navigate into AWS console. Here you can navigate to the Secrets Manager. This is there in My Recently Visited, or you can search it from this search bar above. So you can use Secrets Manager and navigate to that. Inside here, you can store a new secret. This creates a new secret inside our Secrets Manager. There are different types of secret that you can create, like credential for RDS database, document DB, etc. In this particular case, let's choose the other type of secret and create it as plain text. This by default shows as a JSON string, but you can also override this and put a simple value. So let's say 5 in this particular case. And then let's click Next. Let's give the secret a name. So in this particular case, let's name this as My Secret and simply give a description if you need. So let's say this is the count as My Secret. You can optionally provide tags, and you can also provide the other permissions in here. Let's leave this as default and click Next. You can automatically configure for rotation and see how to rotate this, but we will see that in a separate video. For this video, let's leave this as off and click Next and then Store to create the secret. If you hit refresh, you can see that our secret is successfully created. Let's see how we can retrieve this from our application and use this count inside the application. Coming back to our Visual Studio, let's create a Secrets Manager client. So let's call this as client, new Amazon Secrets Manager client, and add the relevant NuGet package. Now this comes from the AWS SDK.Secrets Manager. Now Visual Studio has automatically found the NuGet package from this type. So let's click Install to find and install the latest NuGet package. The package is successfully installed, so let's make sure to include the appropriate usings and then use this client. So once we have a client instance created, we can use the client.getSecretValueAsync method to retrieve our secret. This takes in a new getSecretValue request. So let's use that class and make sure to include the appropriate usings as well and pass in a few parameters. In this case, we need to specify the secret ID. So if we come back to our AWS console and go to the secret, you can get the ID from here, which is nothing but the secret name. So let's copy that and use this in our case. You can also specify a version ID or the version stage. Both of these are optional. If we leave it as blank, it will take the latest version of the secret, which will be the stage that's labeled as AWS current. You can also give an AWS previous if you want the previous value. Let's see that a while later. So let's leave the values as default and simply pass the secret ID only. So once this request is made, let's get back the response. Make sure to add the await call. And since this is await, we need to make sure this method is async as well. So let's press Alt Enter and make the method async. Once we have the response, we should be able to get the response.secretString and convert that as an integer. So in this particular case, let's say a secret string. So let's do an int.parse and convert this response string as an integer. So let's make this as our count and remove the 5 from here. So now we have the count retrieved from the Secrets Manager client and from our secret value. Let's put a breakpoint here and run this application to see this in action. The application is running and launches the Swagger UI, which is defaultly set up for an ASP.NET application. So let's click the get, try it out, and click execute. This hits the breakpoint. If we expand the response, we can see this has the secret and it has the secret string which has the value 5. So let's continue the execution, and this gets the count as expected as 5 and it returns 5 as the hardcode data. Now if we come back to Secrets Manager and if we retrieve the secret value, we can edit this again. So let's click edit and change this value to be 10 and click save. Now a new version of the secret would be created and that will be the latest, and 5 would be the previous one. So let's come back to our API and make a call again. So let's click execute, and this time if we step through the request, we will see that the count is now updated to be 10. This is because we are not passing in a version ID or a stage in our request, because of which it's always getting the latest version, which is 10 in this particular case. So let's click stop. And if we were to pass a stage explicitly, so let's say version stage, and if we use the string AWS previous, this is going to return the previous value. So let's click F5 again and see this in action. So we have the API running again. So let's click execute, and this hits the breakpoint, and this time it's getting the previous stage. So if we look at the value, we can see this is 5. Let's add a quick watch, and we will see that the status code is okay, and the stage in this particular case is marked as AWS previous. This also has a specific version ID which is automatically created when we create a secret inside the AWS portal. You can also use this in the version ID to explicitly refer to this particular version of the secret. So let's continue execution, and in this case this will return back again 5 data only. Now if you want to create a specific version using code, you can do that as well. So if we come back to our client, this supports methods to create a secret as well. So you can see this has a create secret async, which is used if you want to create a new secret. Now if you want to update a value, you will have to use the update secret async method. Now this can also take in a specific version or the stage when you create it from the code. I will let you play around with those example options and see how that works for yourself. So let's remove this. Let's extract this code into a separate method. So let's use Ctrl RM in Visual Studio and change this particular name for this method. So in this case, let's call getCount from AWS Secrets Manager. Now, usually values like this or API keys or sensitive information is managed as application configuration. With .NET, this means you would be putting it inside your app settings.json file. This is how the applications that we build generally use these configuration strings. So let's see how we can easily integrate with the AWS configuration and integrate our application code seamlessly without having to explicitly make calls to AWS Secrets Manager. To do that, let's come into our app settings.json. Let's create a new section. Let's name this as weather forecast. And let's add a new value, let's say count, and give this as a value 5. Now in this particular case, we can use this particular 5 coming from here inside our weather forecast controller. We will then see how to move this into Secrets Manager and easily integrate from our application configuration. So let's come back to our weather forecast controller and replace this count to be retrieved from the app settings.json. Now we can use the options pattern to inject in configurations and option parameters into our application code. If you're new to options pattern in .NET, I highly recommend checking out the linked video here or in the description below. So let's come to the weather forecast class and create a new class. Let's name this as public class weather forecast options, which will hold the settings for this particular class. In this particular case, let's add a int and add in the count property. This is exactly going to match the app settings.json's weather forecast section. Now we can register this options class inside our program.cs. So let's use the builder.services.addOptions method to inject this options class into the dependency injection service collection. So let's specify weather forecast options, which is the new class that we just created. Let's make sure to include the appropriate using statements. Once we have added the options, let's also specify how to bind this. So in this particular case, we can use the bind configuration method and specify the section name. We have specified it as weather forecast inside our configuration. So if you come back to our app settings.json, this is the section that we are binding to. So when the application starts up, this creates an instance of this options class, binds it with this configuration, and gets all the values from there. Inside our weather forecast controller, we can inject in an options class. So let's come to our constructor and let's inject in an iOptions and create it as weather forecast options. So let's make sure to give the right casing and pass this in as options. Let's make sure to include the appropriate using statements and set up this value inside our constructor. So let's create a new backing property for this. Let's create an assign field options. We can explicitly get the value for this options by using the dot value, which will be the weather forecast options class. So let's do that in the constructor. So let's then remove this extra iOptions interface because this is now a weather forecast options class. So we have the options value in here. So instead of getting it from the Secrets Manager, let's now use this as from the options class. So let's see options.count as the value. So let's run this and see this in action. Now this is not talking to AWS Secrets Manager, but this will be retrieving the value from our app settings. So let's see the options.count is the value 5, which is being coming from the app settings.json. Now that the application code is integrated with the .NET configuration, let's see how we can make AWS Secrets Manager as a configuration provider for our .NET configuration. Now, if you're new to .NET configuration and how to set up different configuration providers and how it works internally, I highly recommend checking out my video linked here or in the description below. To integrate the AWS Secrets Manager, we will be using a NuGet package. I will be putting a link to this GitHub repository in the description below. This NuGet package allows us to give support for Secrets Manager as a configuration provider. So let's see how this works in action. So let's copy the NuGet package name. Let's come back to our application. Let's go to manage NuGet packages and install this inside our project. So let's search for this. Let's click browse and search for this NuGet package. So we have this NuGet package here. So let's select and click install. This installs the NuGet package into our application code. Once it's successfully installed, let's come back to program.cs and integrate this inside our application. So we can use builder.configuration and call the add secrets manager method. This adds in the AWS Secrets Manager as a configuration provider inside our application. Now, if we come to our app settings.json, we have the value in a hierarchy. So we have the weather forecast, which is the root of our configuration section, and it has a value inside that, which is count. So let's come and create a new secret inside our Secrets Manager. So let's navigate to Secrets and click Store a new secret. Let's choose the other type of secret, plain text. Let's specify a value, let's say 15 in this case, and click Next. Now for the name, let's give this as weather forecast, which is our root section name, and let's use double underscore to specify the separator. Now in .NET, by default it uses colon, but we cannot use that as a secret name. So we will be using double underscore, and we can specify count as the sub property name. So let's click Next and click Next and then Store. Now this creates a new secret inside our AWS Secrets Manager. Coming back to our application, we need to do a slight remapping so that this name maps to the configuration format that .NET expects. So we'll need to replace the double underscore as a colon. So coming back to our program.cs, where we are calling the add secrets manager, this takes in a configuration. So if we look at the different options, this takes in a property, the configurator, which takes in a configuration options. So let's use the func which this provides. So let's specify config and specify a func and set up the properties. Now the config has a property, the key generator. This is used to transform the key names which are received from the AWS Secrets Manager. So let's specify this property. Let's specify this as a function which is going to take the secret list entry and also the string name. So let's take in the secret and the name and modify this name. In this particular case, what we want is on the name, we want to replace the double underscore with a colon. So let's call the replace method on the string name. Let's specify this as double underscore and replace this with a colon. So anytime a secret is retrieved, it will pass through this generator and transform the name and replace it with colon. Since we are not using the secret, we can discard this inside this function. Let's run this and see this in action. The application has started up. Let's click Get, try it out, and click Execute. Now, if we look at the options, so let's do a quick watch, we can see this value is now 15, which is the latest value from our secrets store. So our application on startup has successfully integrated with AWS Secrets Manager, retrieved this key, and it has replaced this to replace the weather forecast :count property in our config values. The configuration source for Secrets Manager overrides the values that's coming from app settings.json because that is the order in which it is getting registered in here. So we have registered the configuration at Secrets Manager as the final one. The default one would already have the app settings.json. So if you were to stop this, put a breakpoint here and run this, we can see the existing configuration sources inside this property. So if we expand this, we can click sources and you can see this already has 5. And if you expand the results view, you can see the different sources that's already existing. One of which is the JSON source, which is the app settings.json file. I highly recommend checking out the configuration video to learn more about this. When you're working in a local development environment, we generally don't want this to connect to an AWS Secrets Manager. In these cases, we can use the .NET's built-in Secret Manager facility. This is particularly useful to keep the sensitive information out of your application code, but still use it when you're building applications locally on your dev machine. So in these cases, let's see how we can integrate with the .NET Secret Manager for the development environment. If you're new to .NET Secret Manager, I highly recommend checking out my video, which will be linked here and also in the description below. It walks through end-to-end on how .NET Secret Manager works and the internals on how it is working, and different ways you can set up your .NET local environment for working with the Secret Manager. In this example, let's simply right-click on Visual Studio, set Manage User Secrets to enable secrets.json file, which is where we will be storing the secrets. Now this secrets.json is not part of our application code, but will still be used in our application. Let's see that. So let's come back to app settings.json. Let's copy the weather forecast and let's paste this inside the secrets.json. Now this is the exact same section that we have. Now since the count is not a sensitive information, let's create a new value. So let's come here, let's create a new key, let's say API key for example, which will be sensitive. So in this particular case, this could be an API key for an external weather data service. So let's leave this as blank in our app settings.json. Let's come back to our secrets.json. Let's leave count because we don't want to override that, but let's simply give API key. And in this case, let's specify from .NET Secret Manager and press save. Now we have the secrets.json set up. The app settings.json does not have any value for the API key. Let's come into our weather forecast options. Let's create a new property. So let's call this as string and API key. Now if we come into our weather forecast controller, we can start using the API key to connect to an external service. For this demo, I will not be connecting to an external API service, which you would have already guessed by the value for this secrets. So let's simply come into the controller and replace the summary section. So let's remove this. Let's use the options.api key as the value for the summary so that we can see this in our front end. Now with the API key all set up and wired from our secrets.json, let's come back to our program.cs and conditionally register the .NET Secret Manager. So this is particularly useful only for local development environment. So let's add if builder.environment is development. In this particular case, let's go and register the builder.configuration and add user secrets. We need to specify the assembly where the add user secrets is set up, which is exactly the project where we added the manage user secrets. Now this is the current assembly, so let's specify the program.cs class so that it will infer the assembly from that. So we have add user secrets specified, and if this is not the development environment, let's make sure to add the secrets manager. So here we are conditionally registering the secrets manager only if it's not the development environment. Now how does .NET know this is a development environment? This comes from the properties launch settings.json. So here we have the ASP.NET Core environment, which is currently set to development. If this is a different value, this will not be treated as development. I walked through this in detail inside my host video, which will be linked here and also in the description below. Let's put a breakpoint here and let's run this application. Now if we step into it, we can see this is adding the user secrets because this is a development environment. So let's click F5 and this launches our API. So let's click get, try it out and execute. Now this time it hits the breakpoint. Let's do a quick watch and we can see that the API key has the value from .NET Secret Manager. This is because it is overriding the value from the secrets.json, whatever value is there in app settings.json, which is currently empty. So we get that value inside our weather forecast controller. So let's continue the execution by pressing F5, and if we look at the API UI, we can see this all returns from .NET Secret Manager. Now to replace this in our Secrets Manager in AWS, let's come back and create a new secret. So let's use the same way, other secret, plain text, and let's specify this as from AWS Secrets Manager. Let's click next. Let's specify the name similarly. So we have weather forecast __ and API key as the key name. This is exactly the same that we have in our app settings.json. So let's come back and click next, next, and click store. So once that is set up, let's come back to our application. Let's go to the launch settings.json and instead of development, let's make this as test. Let's make sure to update both the profiles and let's also make sure that the Swagger UI is also included even when it's not development. So let's make sure to comment this out so that even if it's not development, the Swagger UI is included. So let's press F5 and see this in action. Now since this is not the development environment, it adds the Secrets Manager and let's continue this execution. Now we have the Swagger UI again coming up. So let's click the try it out and click execute. Now in this particular case, if we were to add a quick watch, we can see that the value is from AWS Secrets Manager and the value 15 that also comes from Secrets Manager. Now this is connecting to Secrets Manager when it's not in a development environment. This is particularly useful so that when you're building applications on your local development machine, you can use the .NET Secret Manager, and when you're using it on a deployed environment, you can use the AWS Secrets Manager. Now with the applications running, now since this is running in the test environment and connected to the Secrets Manager, if I come here and update the count, so let's click retrieve secret value and edit and change this value back to 5 and click save. Now with the value updated, let's come back to our API, click execute again, but if we look at the count, it's still 15. This is because the value is currently not refreshed. So if we look at the program.cs, we can see this adds the secrets manager, but this is only called when the application launches. This does not poll and refresh the values. So let's see how we can get that done. So this config, we can update the config and specify the polling interval and specify a time span. Now this time span will determine the period in which this application secrets will be refreshed. One thing to note is that it will refresh all your secrets. So if you have 10 secrets that is used by this application, 10 API calls will be made to refresh that. So you need to use a value that works for your business and for your application and the nature of your secrets that you're using. So let's specify for demo purposes, let's specify from seconds and give this as 20. So in 20 seconds, this will refresh once an update is made. Now for a real world application, this value will be much higher. It could be in the minutes or hours as well. Now with the automatically refreshed value, we will also need to come into our weather forecast controller, and instead of using the I options, we'll have to use the I options snapshot. Now this interface is useful in cases where the configuration options can change in the background. So once we have specified the options snapshot, there's nothing else that we need to change. So just by changing the interface, we can use the dynamic nature of the options that is getting injected into our service collection. So let's press F5 to see all of this in action. Now since this is not development environment, this is going to hit the secrets manager and load the secrets from there. So let's click get, try it out and click execute. Now this time the count is updated as 5. This is because this is a fresh start. So let's continue the execution. Let's come back to our secrets manager. Let's click edit. Let's update this value to be 15 back again and click save. Now once 20 seconds is passed, our application will automatically hit secrets manager, refresh the values and use that in our options. Now if we come back to our API, click execute again, you can see this value is still 5. So the 20 seconds hasn't passed yet. So let's wait for a few more seconds and click execute again. Now this time, if you look at it, the value is 15. So it has automatically refreshed the configuration from AWS Secrets Manager and made that available to our application. Now since we are using I options snapshot, this updated configuration is also injected into our controllers. Let's continue the execution. And this returns the data as expected. And we can also see the from AWS Secrets Manager is the summary for this particular response because this is using the API key from AWS Secret Manager. I hope this helps you to get started with AWS Secrets Manager and use this from a .NET application. We learned the basic concepts of AWS Secrets Manager, how to create a new secret and use it from our .NET application using the client SDKs. We then learn how to integrate seamlessly with .NET configuration and specify AWS Secrets Manager as a configuration source. We also learned how to set up automatic polling and keep the secrets updated in your application code so that it always has the latest secrets as in AWS Secrets Manager. If you like this video, please make sure to hit the like button. If you have any questions, comments or feedback, make sure to leave them in the comment section below. If you want to be notified of future such videos, please make sure to hit the subscribe button. This also helps me to grow this YouTube channel. Thank you and see you soon.